time to spend more time dealing with the pool and figuring out, okay, here's this chunk of water, that's how big I want my pool to be. So let's start figuring out, we already took a look at how big the water is, or how much water I need as far as volume. I did length, width, and height. But now we have to start figuring out how much dirt do we take out of the ground, how much concrete do we use for the walls and the floor, and how much liner do we need as far as surface area. So what you have to understand is, if you're looking at your yard, I need to take this chunk of water and put into the yard. So I have to dig a hole big enough to cover this. What a lot of kids do is they dig out the hole, let's do this. They dig the hole, but they only make enough room for the water. They dig the hole so it's 25 long, 15 across, and only 5 deep. There's an issue with that. If you take a yard, dig a hole, and then put a chunk of water in it, that's called a pond. You have nothing to keep the dirt away from the water. This hole is not going to be big enough. What you have to do is dig the hole a little bigger so that you have room for the walls. Remember, our walls are going to be 1 foot thick. So not only do I have to have the hole big enough for the 25 and 15, I need the hole big enough to wrap the water with a 1 foot thick wall. Now you're going to have to do some figuring as far as, okay, if the water used to be 25, what is now the new length? What is the length of the entire hole with the concrete on both sides? What is the new width of the hole with the concrete on both sides of the water? And the water was 15 across. What is the new height of the water? Sorry, height of the hole in the ground. The water needs to be 5 deep. So how deep is the hole then? So just remember, when you dig the hole, you must put the water in, plus have room for the concrete to go around. Make up new numbers when you go to figure out the excavation. You must take the water number and make sure you add on the fact that you have room for 1 foot walls on every side. For this next part, I want to take a look at figuring out how much concrete should go in the hole. What I want you to remember is the hole must contain 2 elements. It must be big enough to hold the chunk of water, plus it must have room for the concrete that goes around. So here's the visual I want you to look at. We're going to do a small demonstration. Imagine that this beaker containing greenish water with food coloring is 10. It's a size of 10. That's how big it is. What I want to figure out is how much of this green water, this yellow-green water, will be left. I'm going to take a beaker that has blue water, and this is going to be worth 7. So this is worth 10, it's bigger. This is worth 7. And watch. How much yellow water is in the container? Remember, the big container of 10 now has to have room for the blue 7 and the leftover yellow stuff, the leftover yellow-green water. So the question is, how much yellow water is in there? The yellow water encompasses the blue water. It goes all around it, on the sides and on the bottom. If I remove it again, you'll see that there's not much left. So tell me, how much is left? Hopefully you say 7. If I started with amount of 10, I put in 7 blue to fill it up, the remaining space has to be 3. And I think I said 7, I meant 3. 10 minus 7 is going to be 3. I want you to use the same concept when you think about the hole in the ground. You have the hole in the ground, 2 things must fit in: the water and also the concrete. So think about the demonstration. If you know how much you have to begin with, and you know one of the things that have to fit in, doesn't it seem simple to figure out what's left over? Last part, dealing with surface area. Surface area is going to represent the liner that goes in the pool. Okay, so I dug my hole in the ground. I can't just put water in because it's going to be a pond. Okay, so I put concrete in. Well, you can't just put water in because water up against concrete time after time is going to erode, it's going to crack, it's going to start leaking out. So what do we then do? We put a plastic liner in to act as a big garbage bag to help protect and keep the water away from the concrete. My surface area formula, if you remember, is 2 times length times width, and remember it's batches of 3. 2 times length times width, 2 times length times height, 2 times width times height. So I have 3 batches of a similar calculation. The point I want to show is this: why is there always a 2 in it? Well, here's why. If you look at this shoebox, how many different sized rectangles are there? Well, there's 3. There's the bottom and the top are the same size. You have a long, thin side. There's 2 of those. 1, 2. And there's a small rectangle. 1, 2. So that's why there's a 2 in it, because there's 2 of the big rectangles, 2 of the long, thin rectangles, 2 of the short rectangles. That's why there are 2's in this formula. Surface area will find the coverage on every side of this box. The difference is, when you look at a swimming pool, you don't want to cover all the sides. If you count the rectangles in a swimming pool, there's not 6, there's only 5. 1, 2, 3, 4, and 5. So before you use this formula, you cannot leave 2, 2, and 2 in the formula. That's 6 sides. You only have 5 sides. So I'm going to leave this up to you. You have to decide which of these 2's have to change. Good luck.